All right, welcome to Lab 1. Since you haven't had LabVIEW, I'm making a quick video on how to go to do this. So basically in LabVIEW, we're going to have our front panel. This is the user interface, and then the programming is done as a block diagram. And so what we're going to be doing is acquiring a sound, displaying that, looking at an FFT of the signal, displaying that, then figuring out the max of the peak of the signal as well as the frequency of the signal. And we're going to plot those on the front panel. And we're going to keep on running. This is a loop, that's the arrows, until we hit the stop button on the front panel. So we basically want to go into LabVIEW and then hit create project, and it basically walks you through that. And I'm going to go through it in the video as well. So create project. You want to do a blank VI. Projects are needed if you want to make an executable of your file, but we're not going to go that far. So now we want to create our front panel, so we need two graphs as well as a meter and a gauge. And so here we can right click and then graph, and it's a waveform graph. Somehow it got really small. You can resize it and then control drag for your second graph. And then under numeric, so it's a single number rather than a bunch of things, we can do a gauge, and we can do a meter. And notice when I click here, it also clicks here, and so these are sort of the relative locations on the screen. So these are things we're going to be wiring to. If you create it on the front panel, it shows up on the block diagram as well. And then we can adjust things on here. So like on the gauge, we can start, we want to go up to 10,000. We want to start at 10. And then if we right click on this, we can do mapping and do logarithmic because the frequency our ears basically handle logarithmically. Similarly for this, we can do -40 up to 0. And if we wanted to change the name, we can just double click on it. And when we change it on the front panel, it also changes on the block diagram. I'll let you finish doing this yourself. One other thing here, our frequency. So here we want to go from 10,000 to 10. And then we want, again, mapping. We want logarithmic. And then we don't want to auto scale. So that's a little hint for that. So now we can go to the block diagram. And so we basically want to acquire a sound, do some analysis on the sound as well. So to acquire, we're going to be using, in this case, express, and then input, and then acquire sound. And we only want one channel. We don't need a stereo signal. We're just wanting to look at the frequency. Everything else should be set, and you should be using the USB mic for it to work on the PCs. So there is our data, and now we can wire our data from here to, let's say, waveform graph 1, and this one we want to be our time. This is our frequency. So basically you can change names on either the front panel or that, and then we want to now process it. But again, we're doing express signal analysis, and we want spectral. So spectral analysis, and since this is express, it basically helps you through. So what do you want to do? We're wanting to look at the magnitude in dB. Let's do no window, and that should be good enough, if I remember correctly. And now it basically sets this up, and so now you have your FFT output here, and then you just wire your signal in, and now it matches the data in is data out. So these are express, and they modify things to make it easy to work with. The disadvantage is you can't do exactly what you want, so we'll learn how to do basically stuff in the background beyond this. And so now we have our FFT. So we can wire that into our frequency. And now we need to figure out where the peak is going to be. And so under Express, under signal analysis, we can do statistics. And what statistics, we want to figure out where the maximum is and the time of the maximum, which in our case is the frequency. And so then you wire your signal in here. So it's assuming you're getting a time signal, but what we're wanting is a frequency. And then the peak should go to the maximum, and the gauge should go to the time of the maximum. And so now we have things basically set up. To clean up your diagram, you can click on the magic broom, and now everything is set up. And now, if everything is set up right, we basically have a white run arrow. And if we hit run, if everything works right, we get our data, we get our Fourier transform of the data. We have our peak and we have our gauge. The peak here is a little bit over 100, which is like that, and it's minus 40 because it's just background noise. What would be nice if this would continually run, and so we can go into our block diagram, right click on this, again under express, execution control, while loop. You do like that, draw around what you want to do in the loop, and it, under express, it automatically adds a stop button. If you just went over here and did the while loop, it doesn't add the stop button. So you'd have to right click on this, create control, and now we have a stop button. So we have two stop buttons. If you don't like it, select it, hit delete. So now it's in a continual signal. Continue analysis. So now we can come over here, hit run. Now it's continually doing the thing. And so basically the frequency should show up if we have a single tone. And there is the signal I have right there. It looks like we have to go much smaller, so, and then we go and as the frequency changes, it's basically going back and forth, and it's showing you where the frequency is and the magnitude there. When we're done, we can hit stop. So this is the stop button that was created here, and then we can drag it where we want it to be, and then we can change the scaling on that as well. So that's how quickly you can basically acquire a signal, do a Fourier analysis on it, and then do further analysis.